guys. So this is the schedule for the next 2 weeks. We have 2 weeks till Christmas break if you didn't realize it. Today and tomorrow we're doing something called systems of equations. Systems of equations just means there are multiple equations, and we're going to work on solving them by graphing. When you get into high school next year, you're going to learn how to solve them other ways, but for 8th grade, we just learned how to do it by graphing. On Thursday is our homework and vocab day. Friday, you're going to do a review on your own. And then on Monday, you're going to go over that review sheet. I haven't decided yet on Friday if you're going to turn in the review or not, but on Monday, we're going to go over the review sheet. I might give you the answers to it. Students in class will be able to ask questions. You can always email me questions. And then Tuesday, you have a test over it. So that is the next couple days schedule in this class. For the vocab, I do want to go over how to do the vocab at the end of this lesson because I do have some of you still messing up on your vocab. All right, so we're going to start by looking at yesterday's page again. This might not be from yours because I just randomly picked a journal. But we have y equals mx plus b, which I told the students in class, this is called the slope-intercept form, and it will most likely be a test question. So be prepared to know that that is your slope-intercept form. My slope is m, and it is how I move, and I move by doing rise over run. My rise is up or down, rising up if that top number is positive, rising down if that top number, that numerator, is negative. Now my denominator is my run. My bottom number is my run, and I run left or right. To the left is a negative, and running to the right is if it's a positive number. So for instance, 1/3, I'm going to go up 1 and to the right 3. If I have a number by itself, like I did for number 6 down here, I'm just going to stick it over 1 so that I have a rise and a run. My y-intercept is my b. It's where we begin. It's where it crosses the y-axis, and it's where I'm going to begin with it. All right, so that's just a refresher from what we did yesterday. Sorry that I, at the beginning of the day, forgot to attach yesterday's paper. Anytime that happens, just send me an email. Thank you to the student who sent me an email. Between 101 students and 2 classes that are online, it's a lot going on in this brain, so thank you very much for the help. Sorry that I made that mistake, but let's go ahead and we're going to look at these examples. Now, as always, I know I have a few of you who print this out, which is probably the best solution, but I know not everyone has access to that. So, if not, then you need to get some grid paper and you need to cut. See, this is 1, 2, 3, 4, 5, 6. So 6 by 6, you need 4 6 by 6 grids. And if you need to stop to do that, you may go ahead and stop and do that now. All right, so sorry I'd already started writing on this because this is my second time making this video. I had a mistake on the first one. So for example 1, I want you to write example 1 in your journal. I want you to write these 2 equations down if you're doing this by hand. Y equals 1/3 x minus 3, and y equals negative 2x plus 4. You'll notice that there's a bracket. Anytime we are talking about systems of equations, there's going to be a bracket there. Okay? All right, so our slope-intercept form is y equals mx plus b, where my m is 1/3. And my b is negative 3. Be sure to bring that subtraction with you when we're writing down our y-intercept. I'll give you a second to do that because I know I already have it written down. All right, so the second one, again, I have an m of negative 2, which I'm going to stick it over 1. And I have a b of 4. All right, so what I'm going to do is I'm going to graph both of these on the same piece of grid. Okay, now I'm going to do mine in color just because it shows up a little bit better graphing than the pencil does in the video. All right, so I'm going to start with this first one. So B is where we begin, so we're going to begin at -3. So I'm going to put a dot at 1, 2, 3. It's not labeled for us, so we're going to have to count it out ourselves. Yeah, it shows up. Okay, and then I'm going to rise 1 and run 3. 1, 2, 3. Rise 1, run 1, 2, 3. Now, our reverse of that is we went up, so now we're going to go down 1, and we went to the right, so now we're going to go to the left. 1, 2, 3. Down, 1, 2, 3. And we want to fill up the graph, and we do want to use our ruler to make sure that our lines are straight. Put arrows in the ends. All right. So something that we probably should have talked about yesterday, so I'm sorry, is that this line are the solutions to this graph. Meaning any point on this line, even if I were to extend this line all the way out to here, whatever that x and y value would be of that point, if I plugged it in, it would be true. Even if I did the halves and the 1/3 that are between these, all of these little bitty points, every single one of them is a solution that if I plugged it into that equation, it would be true. Okay, so all of these are the solutions, possible solutions to this, to the top graph. Sorry. All right, so now let's graph our bottom one. Okay, so we're going to start at 4, because we're going to begin at 4. 1, 2, 3, 4, and put a dot. And we're going to go down 2, 1, 2, over 1. Down 2, over 1. Down 2, over 1. Down 2, over 1. Down 2, over 1. Filling up our graph, I can do a reverse one also if I want to. We want to fill our graph. I know I said that a lot in class, so I don't remember if I said it a lot in this video last time, but we want to fill up that graph, because what we're doing for systems of equations is this is the solutions to all of this graph, and this is all of the solutions to this graph. So what we're wanting to know is what is a solution that would have worked for both graphs. So this is a solution to one of them, and this is the solution to the other one. The only place they have in common is this point. So let's look at this point. It's the x value. So remember, we do x, comma, y. Our x value was 1, 2, 3. And our y value was 1, 2, -2. All right. Now, I don't want you to write this next part down. I just want to show you how that works. So, I have the equation y equals 1/3 x minus 3. And I have x is 3, so I'm going to replace that x with a 3. And my y is a -2. 1/3 times 3 is just 1. 1 minus 3 is -2. So it was true. So it worked for that one. But let's also look and see it needs to work for both equations. So I had my x of 3. And I'll plug in my y value, -2. -2 is going to stay the same. So -2 times 3 is -6. -6 plus 4 is -2. So it was true. So that point, 3, -2, works for both of those lines. It's true for both of them. So it is a solution to the system of equations. So we're going to be looking for where they intersect. Okay. Let's look at number 2. So we have a slope of -2, so I'm going to stick that over 1. And we have a y-intercept of -1. So I'm going to go ahead and graph that. So -1. And then down 2 over 1. Down 2 to the right 1. do its reverse, up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. So hopefully we're getting really good at graphing. I know my in-class students were doing really, really well at graphing, so I'm hoping y'all are too. Alright, and so now we're going to graph our second one, which was x plus 5. So remember there's an imaginary 1 there. So my slope is 1, so I'm going to go ahead and stick it over 1. And my y-intercept was 5. So I'm going to go to the 5. 1, 2, 3, 4, 5. And the reason why these graphs are marked out is because the form they're written in, y'all haven't learned yet. So it's just me changing it to a easier form for y'all. And then we're going to go up 1 over 1, up 1 over 1, up 1 over 1. But I ran out of room, so now I got to do the reverse. Down 1 over 1, down 1 over 1, down 1 over 1. And I want to fill up that graph because I told y'all, I think I told y'all in the video too, sorry. I want to make the videos on Fridays like I did for y'all's Monday video. Kind of forget what I said. We want to see what's happening to this graph, so we want to see the full picture of it. And look, they crossed. So that point is going to be my solution. So negative, my x value is negative 1, 2, so negative 2. My y value is 1, 2, 3. And I can plug those into both of them to make sure that it works. And it will. Alright, so let's look at example 3. So these, example 3 and 4, so I'm not giving you time to write down these equations. Sorry, go ahead and write down both of these equations if you didn't print it out. Example 3 and 4 are unique situations, and we're going to look at these two unique situations because they do happen. So I'm going to give you about a minute to get it down. Alright, so hopefully you've gotten it down by now. So my slope is negative 3, and I'm going to go ahead and stick that over 1, so I have a rise and a run. My my y-intercept, is 2. So I'm going to come and go to where I begin. Put a good dot. Negative 3 tells me I'm going to go down 3. 1, 2, 3. Positive 1 tells me I'm going to go to the right. If you don't remember how to do that, then I suggest looking at yesterday's notes again. And we want to do it to reverse. Up 3, over 1. And I want to encourage you to always fill up your graphs. Because when you get into high school, you're going to do a lot of graphing. And it's going to become very important that you see what's called the end behaviors of a line. That's the ends of the line and seeing what they are doing, what their behavior is. And so just get in the habit of filling up your graph, filling up the whole coordinate plane, because it becomes important in high school that you see what happens to those. All right, so for the second one, my slope, again, is negative 3, and I told you this was a unique situation, so maybe it has something to do with the same slope. And my y-intercept is negative 4. I went ahead and stuck that over 1. Hopefully, sorry I didn't explain that. So we're going to start at negative 4. 1, 2, 3, 4. And we're supposed to go down 3. So I'm going to go ahead and mark this. It's supposed to be down 3. And to the right 1. But I can't do that. I ran out of space. So I'm going to do its opposite. So I'm going to go up 3. 1, 2, 3. And to the left 1. 1, 2, 3. To the left 1. 1, 2, 3. To the left 1. And I'm going to go ahead and draw that line. Now, I'm going to ask my students in class, what do they see? What do they notice about this? I'm hoping that just like them, I'm hoping you're thinking, well, they don't cross. That's true. And so then I need to ask myself, are they ever going to cross? Maybe I just didn't look at enough of the graph. Maybe if my graph was bigger, eventually they're going to cross like way up here or something. So I need to look at that and I say, okay, are these going to cross? And so let's look at this by looking at an index card. Maybe this will help us see it. Okay, so here's a little piece of an index card, maybe. And it looks like my graph right here is that far apart. But if I look, no matter how much I go up, they're always that far apart. And so my next question I'm going to ask my class is, what's that called? And I'm hoping that just like them, that you're going parallel lines. Parallel lines. Parallel lines. And when they are parallel, it means they're not going to cross. So there is no solution. There is no number in the entire world, no plot, no point in the entire world that works for both of these. Ever. Because they're never going to cross. Okay? Hopefully that makes some sense. If not, please shoot me an email. Alright, let's look at example 4, which I also told you was a unique situation. So let's look. So I have a slope of 1/2 and a y-intercept of -2. So let's graph that. So -2, rise 1, run 2, rise 1, run 2, rise 1, run 2. And do the reverse. Down 1 to the left 2, down 1 to the left 2, down 1 to the left 2. Oh, sorry. Give you some time to copy that down. Copy the equations. I'm sorry, I forget sometimes. But you'll need a little time. Hopefully you are just pausing the video if you need to. But I'll give you a minute or two to get that copied down. Alright, hopefully you've gotten that down. For the second one, I have a slope of 2/4 and a y-intercept of -2. Okay, so I'm going to start at the same spot. I'm going to rise 2, run 4. 1, 2, 3, 4. Rise 2, can't do that, so I'm going to go back to my original point. Maybe I need to do this one in a different color. Maybe that'll help see. I'm going to start here also. Rise 2, run 4, left me right there. Go down 2 and over 4. Connect those points, which we shouldn't have to, but hey, why not? That blue overtakes that pink by a lot. Oh my goodness. We can see they are the same line. And so I'm going to ask my students in class, what do we think that means? What do we think it means? And I'm hoping that someone somewhere says, every single number is a solution. And that's the truth, because all numbers are solutions. Okay? So we have no solution and all solutions. So how we would say that is there's infinite solutions. I know you've heard of infinity, to infinity and beyond. That means forever. That means there's an endless number of solutions. So there's an infinite number of solutions. Alright, so that is just our intro to systems of equations. Tomorrow we're going to do a lot of practicing on it. I have 8 of them, or I have quite a bit graphs for us to practice tomorrow on. So we will be spending the entire time practicing. This needs to be on page 32 of your journal. 32. So I'm going to fold it and put it on page 32. So those of you that have it, you're going to fold it in half and glue it on page 32. Those of you that didn't, you should have cut out your own graphs and graphed them. Be sure that they are labeled with which number they belong to, like which example they go to, because you know on that journal test, it's going to have it based on the example numbers. Alright, so that's page 32 of our journal. Alright, and that is all I believe we're going to be putting in our journal before Christmas. Alright, I'm going to pull up the teams, and I want to show you how you can do your vocab real quick. Those of you who have been doing great on vocab, you can stop the video now if you would like. Alright, so yours might look a little bit different than mine, but it's the same concept. So this was last 6 weeks vocabulary assignment, and I know some of you are doing a great job at this, but I still have quite a few of you who aren't. So I want to show you. You always need to start by typing in your name. So I'd come up here and type in Joel, Miss Joel. Last names are nice. I do have a lot of duplicate names this year. Like I said, I have over 100 students, so that works. In this, you were supposed to type your definition. So I'm going to come in and type y equals mx plus b. This is the format of linear equations, where m is the slope and b is the y-intercept. The y equals and x are always the same. And I can even move this line up if it's too much. If I want it smaller, I think I can. Well, it's not letting me, but I can come and delete some of that space down here. And then it'll let me move, yeah. And then I'm going to highlight or underline. So let's say I think that B is the y-intercept is important. Then when I do that, it gives me the option to underline or highlight. And then all I have to do is literally, if you know how to copy and paste, you can just copy that and paste it. I have some of you who did that. And then go to an example. And I don't even care if you go to Google and look up an example. But I know y equals 3x plus 4 as an example. And then I click on the next box. And when you're done, you just push submit. Alright, and that's it. I have some of you who are having trouble figuring that out. I'm going to delete this because, yeah. Some of you who are having a little bit of trouble figuring that out. So just wanted to let you know how that's starting. So you'll have vocab on Thursday. Y'all have a great day and God bless y'all.